Hi folks, I'm Say Karthikeyan, working as an assistant professor in the Department of VC from R.M.K CET. Today in this session, we will be discussing about analog to digital converters. So the objective is to brief the outline, the principles and working of ADC. Usually, analog to digital converters. So the basic principle of this converter is the analog input will be fed as an input, which is nothing but my analog waveform, has been converted into binary output with zeros and ones as my digital output. So this is the basic principle behind analog to digital converter. There are different types of ADC and few are listed here. First one, flash type ADC is also called as parallel comparator. The second one, successive approximation type ADC. Third, single slope ADC. The fourth, dual slope ADC. And today we will be discussing about successive approximation type ADC. First, successive approximation type ADC. It starts with two commands. First, we call this as SOC, start of conversion, and EOC is called as end of conversion. SAR acronym is Successive Approximation Register. As we all know, the registers will be enabled by supplying the clock in order to trigger the register or enable it to turn on. And here we have a comparator with two input VA analog voltage connected to the negative terminal, and my positive terminal of my comparator is connected to the output of DAC, which is nothing but VD, digital voltage. So here SAR, successive approximation register, is used to provide the digital output. So the output of each D1, D2 till D8 is being obtained here. As we know, D1 is nothing but my most significant bit, and then the D8 is nothing but my least significant bit. So this is 3-bit ADC. So 2 power n is equal to 2 power 3 is equal to totally 8 digital outputs. So we have two commands. First one is SOC, start of conversion, and EOC is nothing but end of conversion. So it provides when to start the conversion and when to end the process of conversion. SAR, successive approximation register, which will be enabled by applying a clock, and we have 8 outputs, and D1 is denoted as MSB, D8 is nothing but the LSB, is fed into the DAC digital to analog converter. So the output is being obtained digital voltage is being compared with the analog voltage, and based on certain conditions the output is being selected. This is the overall circuit diagram of successive approximation analog to digital converters. So the comparator with two input analog voltage VA and the digital voltage VD, and we will be getting an output X. X is nothing but the comparator output. If my VA is greater than VD, my analog voltage is greater than that of my digital voltage, my comparator output is 1. If my analog voltage is less than that of my digital voltage, my comparator output is equal to 0. Consider the input voltage, this correct digital representation, as V suffix A, analog voltage. So analog voltage has a binary input of 1 1 0 1 0 1 00, and the second column represents the successive approximation register SAR output VD at different stages in the conversion, and the third column represents the comparator output. First, initially my comparator output is 1, and first my MSB is turned 1. MSB of that 8-bit so is turned 1, and compare the analog input voltage and the VD. So convert this into decimal number and compare the VA and VD. If my VA is less than VD, my x is equal to 0. If my VA is greater than VD, my x is equal to 1. So first condition, VA is less than VD. So when my VA is less than VD, so here we will just turn the next bit, that is my second bit, to be 1. Compare the first and the second, VA and VD. So if it is less than, we will be providing it as 0. If it is greater than, it will be provided as 1. So here we will be again converting this into a decimal equivalent number. Compare the two bits of number, with the condition VA is less than VD, so it will be 1. If my VA is greater than VD, so I will be providing my output as 1. And look at in this case, so my VA is greater than VD, so I obtain my output as 1, and in which position it was turned, so that position has to be turned to 0, followed by the fourth position, and then the fifth position, 6, 7, 8. So till the VE, we reaches a position that is more than VE. So if we get more than the initial applied voltage VA, so we will start EOC, that is end of conversion process will be happening. And here it's a graph where my output voltage, which is nothing but my digital voltage, it becomes successively closer to actual analog input voltage. So my ADC digital output has been obtained here, and my with respect to time, so this conversion indicates how far the digital output voltage is successively very close to the analog input voltage. Thank you.